Today we are going to learn about precision versus recall, balancing trade-offs. In this session, you will gain insights on optimizing model performance by mastering the balance between precision and recall, a critical skill for aligning model outputs with specific business objectives.
Welcome to our session on precision versus recall, balancing trade-offs. In the realm of model evaluation, understanding precision and recall is paramount. Precision measures the accuracy of positive predictions, while recall determines the coverage of actual positives. Achieving the right balance between these two metrics is essential, especially when dealing with environments where different types of errors bear varying consequences. This session will guide you through the complexities of these trade-offs, helping you optimize your model's performance to meet specific business goals. Let's dive in and explore how precision and recall can be strategically managed to achieve the desired outcomes. Precision is a crucial metric in model evaluation, particularly in binary classification tasks. It is defined as the number of true positive results divided by the sum of true positive and false positive results. Essentially, precision tells us how many of the predicted positive outcomes were actually correct. A high precision value indicates a low rate of false positives, which is especially important in scenarios where false alarms can lead to significant consequences, such as in fraud detection or medical testing. Precise models ensure that when a positive label is assigned, it is with a high degree of confidence. For instance, in a cancer screening test, high precision means most of the identified cases are indeed cancerous, reducing the stress and costs associated with false positives. Understanding and emphasizing precision helps in creating models that are reliable and trustworthy in critical applications.
Recall, also known as sensitivity or true positive rate, is a measure of a model's ability to identify all relevant instances within a dataset. It is calculated as the number of true positive results divided by the sum of true positive and false negative results. High recall indicates that the model is effectively capturing all the positive instances, minimizing the chances of missing out on actual positives. This is particularly critical in situations where missing a positive case could be costly or dangerous, such as in diagnosing diseases or detecting fraudulent transactions. For example, in an emergency response system, high recall ensures that all genuine distress signals are detected and acted upon promptly. By focusing on recall, you ensure that your model does not overlook important positive cases, maintaining comprehensive coverage of the target classes. The precision recall trade-off is a fundamental concept in model evaluation, reflecting the balance between precision and recall. When you increase precision by making stricter criteria for positive predictions, recall often decreases because some true positives might be missed. Conversely, boosting recall by relaxing criteria can increase false positives, reducing precision. This trade-off is crucial in fine-tuning models to meet specific business requirements. For example, a model designed for spam detection may favor high precision to avoid marking legitimate emails as spam, whereas a model for emergency alerts might prioritize recall to ensure no threat goes unnoticed. Visualizing this trade-off using precision recall curves helps in understanding the optimal balance point, where both metrics are aligned with the application's objectives. By strategically adjusting thresholds and utilizing techniques like cross-validation, you can manage these trade-offs effectively, ensuring your model performs optimally in its intended context. Prioritizing precision over recall is essential in situations where the cost of false positives is high. Such scenarios include fraud detection, where false positives can lead to unnecessary investigations and expenses, or in medical testing, where a false positive might cause undue stress and additional testing. In these cases, a model with high precision ensures that when a positive result is indicated, it is highly likely to be correct. For example, in financial institutions, precision-focused models help minimize the risk of labeling legitimate transactions as fraudulent, maintaining customer trust and operational efficiency. To achieve this precision, models can be adjusted by setting higher decision thresholds, using precision-optimized algorithms, or implementing post-processing rules to verify predictions. Ensuring high precision aligns model outputs with critical business objectives, reducing the chances of costly mistakes.
Class imbalance occurs when the number of instances of one class significantly outnumbers the other in a dataset. This imbalance can adversely affect both precision and recall, leading to biased model performance. In imbalanced datasets, a model might achieve high accuracy by predicting the majority class, but this doesn't necessarily equate to high precision or recall for the minority class. For instance, in a fraud detection system, where fraudulent transactions are rare compared to legitimate ones, a model might miss most fraudulent cases, low recall, or incorrectly classify legitimate transactions as fraudulent, low precision. To address this, techniques such as resampling, synthetic data generation, or using specialized algorithms that account for class imbalance are employed. These methods help improve the model's ability to correctly classify minority class instances, thus balancing precision and recall even in challenging datasets. Calculating precision and recall using Python is a straightforward process, thanks to libraries like scikit-learn. By using the precision_score and recall_score functions, you can easily compute these metrics for your classification models. Let's walk through a practical example. First, you need to import the necessary libraries, NumPy for data handling and scikit-learn for model evaluation. After fitting your classification model, you can use the predict method to obtain predictions on your test set. Then, apply the precision_score and recall_score functions to calculate precision and recall based on your predictions and actual labels. Interpreting these scores helps you understand your model's strengths and weaknesses in terms of precision and recall, guiding you in making informed adjustments for optimal performance. This hands-on approach in Python not only makes the process efficient but also allows for easy integration into your model evaluation pipeline. Balancing precision and recall is a strategic endeavor that requires careful consideration of various techniques. One common method is threshold adjustment, where you modify the decision threshold to achieve the desired trade-off between precision and recall. This is particularly useful in binary classification tasks. Additionally, selecting and tuning the right algorithm can significantly impact the balance. For instance, tree-based models or ensemble methods might be preferred for their flexibility in handling class imbalance. Cross-validation and grid search are invaluable for exploring different parameter settings, ensuring your model is optimized for both precision and recall. Regularization techniques can also help by penalizing overly complex models, reducing the risk of overfitting. Industry-specific strategies might involve domain knowledge to guide model adjustments, ensuring alignment with business objectives. By employing these strategies, you can effectively balance precision and recall, tailoring your model to meet the unique demands of your application. Different industries require distinct balances of precision and recall based on their specific needs and consequences of errors. In healthcare, particularly in diagnostics, high recall is often prioritized to ensure that no potential case is missed, which could endanger patient health. Conversely, in finance, especially in fraud detection, precision is crucial to avoid false positives that could lead to customer dissatisfaction and operational inefficiencies. Marketing and customer segmentation may also prioritize precision to ensure targeted campaigns reach the correct audience without unnecessary expenditure. Each industry must carefully tailor its models, considering the potential impact of false positives and false negatives on business objectives. By understanding these industry-specific trade-offs, you can better align your model's precision and recall with the strategic goals of the organization, ensuring that your predictive models provide the most value. Visualizing precision recall curves is an essential practice in understanding and optimizing the trade-offs between these two metrics. Tools like scikit-learn provide robust functionality for generating precision recall curves, enabling you to visualize performance across different threshold settings. By plotting these curves, you can easily identify the threshold that offers the best balance between precision and recall for your specific application. Interpreting these curves involves examining the area under the curve, AUC, where a larger AUC indicates better model performance. Additionally, these visualizations can guide you in adjusting model thresholds to achieve desired precision recall levels. The practical application of these tools in model tuning ensures that your predictive models are not only accurate but also aligned with the strategic goals of the business, maximizing their effectiveness in real-world scenarios. In conclusion, understanding and balancing precision and recall is critical in model evaluation, especially in scenarios where different errors have varied consequences. By delving into the nuances of these metrics, you can make informed decisions that align your model's performance with specific business needs. We've explored practical applications across industries, visualization techniques, and strategies for managing trade-offs. These insights empower you to optimize your models effectively, ensuring they meet the desired objectives and deliver meaningful results. As you continue to refine your models, remember that the balance of precision and recall is a dynamic process, requiring ongoing assessment and adjustment to achieve optimal performance.